Are you using microservices architecture? Are you having trouble implementing integration patterns between microservices and different applications? Enterprise integrations can be very complex. Apache Camel simplifies enterprise integrations and makes it easy to communicate with queues, databases, file systems, and a number of other endpoints. I am Ranga Karanam. I'm the founder of In 28 Minutes and creator of some of the world's most popular courses on microservices, cloud, and DevOps. In this course, you'll learn the fundamentals of Camel, endpoints, routes, processors, transformations, and a lot more. You will learn how to use Camel to solve your enterprise integration problems. We will use a hands-on approach in this specific course. We'll be integrating Apache Camel with Spring Boot. We'll be using a variety of Spring Boot starters and helping you talk with a number of queues like Kafka, Apache MQ, and we'll also play with different file systems. We expect you to have good knowledge on Java and Spring Boot. What are you waiting for? It's time to solve your enterprise integration problems using Camel. I'll see you. Welcome back. In this step, let's get a 10,000 feet overview of Apache Camel. What is the problem that Apache Camel solves? Enterprise integrations are very complex. Whenever we talk about enterprises, they have hundreds of applications, if not thousands of applications. These applications have complex communication patterns and they use variety of transports, HTTP, queue, etc. And they use variety of protocols, HTTP, JMS, AMQP are just a few examples. And also the evolution of cloud and microservices makes enterprise integrations even more complex. You can look at the communication patterns between these microservices in here. If you look at microservice 4, it is interacting with almost 6 microservices. And it might be using different transports to communicate with each of the microservices. Microservice 4 might be calling microservice 5 as a REST API. However, to talk to microservice 6, it might be using a queue. Even when talking to a queue, there are a wide variety of protocols and communication approaches that are involved. How do we simplify enterprise integration? How do we simplify the code that we write to enable microservice 4 to talk to other microservices? How do you ensure that it is adhering to all the best practices? What you can do is to try and follow enterprise integration patterns. However, understanding enterprise integration patterns and implementing them well is a big challenge. The best framework in this specific space is Apache Camel. Apache Camel is an open source enterprise integration framework. You can easily integrate systems which are consuming or producing data. Apache Camel is actually inspired by a book called Enterprise Integration Patterns. Gregor Hope and Bobby Wolf wrote this amazing book with all the patterns that are involved in doing enterprise integration. And Apache Camel is inspired by that book. In the last decade, we have evolved to microservices architectures. And a lot of enterprises today use cloud to deploy your applications. In addition to the patterns which are in the book Enterprise Integration Patterns, Apache Camel also helps you to implement patterns around microservices architectures and cloud. One of the important things about Apache Camel is that it is very lean, it is very lightweight and extensible. Apache Camel helps you to integrate with a variety of other applications. You can integrate with Kafka, ActiveMQ, you can integrate with applications which use JMS. You can make HTTP calls. You can talk to cloud services like AWS Lambda. And in spite of enabling you to do all these, Apache Camel is lightweight. The reason is because Apache Camel uses something called a component architecture. There are hundreds of different components which are provided for different databases, message queues, APIs, and cloud integrations. Apache Camel also supports 200 plus protocols, transports, data formats, and 300 plus converters between these data formats. Apache Camel also provides a domain-specific language, a DSL, which is customized to the needs of application integration. We have a couple more slides where we'll be talking about Camel terminology and the architecture. But before we bore you with all the theory, let's get started with implementing a simple example with Apache Camel in the next step. Welcome back. In this step, let's create a simple project to use Apache Camel. What we'll do is we'll use Spring Boot to simplify the configuration around Camel. So I'm on my favorite website on the internet, start.spring.io, and let's go ahead and create a Spring Boot project that helps you to use Camel. So I'm choosing Maven. Language is Java. You can use any of the latest versions of Spring Boot. Do not use snapshot versions and do not use milestone versions. The group ID I would use is com in 28 minutes, and I'll call this microservices. And over here, the artifact ID I would be using is camel microservice A. We'll create a couple of microservices. We'll call them A and B. So com in 28 minutes microservices, camel microservice A. I'll call this demo project for Camel. And let's choose the dependencies. The first one I'll choose is Spring Boot DevTools. Spring Boot DevTools provides fast application restarts, live reload, and it provides you with enhanced development experience. We'll see what it brings to the table a little later. For now, let's just add it in DevTools. The other things I would add in are web. We'd want to build a REST API at a later point in time. So let's add in Spring Web. In addition to this, we would want to add in Actuator. It provides a lot of endpoints which will help you to monitor and manage our application. So I'll add in Spring Boot Actuator. And the next thing I would add in is Camel, Apache Camel. Apache Camel is an open source integration framework that empowers you to quickly and easily integrate various systems consuming or producing data. So let's go ahead and add Apache Camel in as well. So we have 4 dependencies. That's very important. Spring Boot DevTools, Spring Web, Spring Boot Actuator, and Apache Camel. That's all we need. Let's go ahead and say generate. So this would create a zip file which would be downloaded to your local machine. What I would recommend you to do is to unzip the zip file and copy to a folder on your local machine. Now, what I would also recommend you to do is to create one more project. With exactly the same dependencies, we'll create Camel microservice -B. And you can click generate for this as well. So we are creating 2 microservices, Camel microservice A and Camel microservice B. What I've done is I've extracted both the zip files which are downloaded to Camel microservice A and Camel microservice B. And now I can go ahead and launch up my IDE Eclipse. You can launch up any of the latest versions of Eclipse. I'll go ahead and say launch. Now we are on the Eclipse welcome page. I'll close the welcome, and over here I can import projects in. So what I would want to do is to go and say file, import. So type in Maven and choose existing Maven projects and go ahead and say next. And now you can choose the directory where you unzipped your files to. I've unzipped the projects to Camel 02 projects. I'll say open. And this should bring up 2 projects, Camel microservice B and Camel microservice A. And you can go ahead and say finish. So this would import both the projects in. If this is the first time you're using that specific version of Spring Boot, or if this is the first time you're using Camel, the download would take a little while. If you click the arrows in here, you should be able to see that it's importing all the projects in. If you have any problems with the import, then make sure that you are using the latest version of Eclipse IDE. I'm using Eclipse IDE for enterprise developers, and that would be recommended for you as well. Now, while the project is being downloaded, let's open up the pom.xml for microservice A. The font size is too small, so let's zoom in a bit, Control plus or Command plus. I think this is cool. So you can see most of the stuff on the screen right now. One of the things you can observe over here is when I open up a file, pom.xml, you can see which folder the pom.xml is in over here. So camel-microservice-A. So whenever we are editing files, make sure that you are editing the file in the right project. So we have 2 projects, Camel microservice A and Camel microservice B. And whenever we are editing a file, you can check whatever is in here to make sure that we are editing the right file. Since this is directly in the root, you can also see the project name in here, Camel microservice B and Camel microservice A. Now, if you look at any of these pom.xmls, they should be very, very simple. All that they should have is a dependency on actuator, a dependency on starter web, dependency on Camel Spring Boot starter, and a dependency on Spring Boot DevTools. You can see that the Camel version that we are making use of is 3.7.0. One of the things I don't really like is hard coding the version in here. So what we'll do is we'll actually create a variable for the version which is in here. So you can copy the version which is present in here, 3.7.0, and I'll call this camel.version, and you can put that in here. And now I can use the camel.version variable in our project. So let's go ahead and say $this. Right now it does not make a huge difference, but you'd see that as we add more dependencies from Camel, it is good to have the Camel version at one place. So that's cool. What I'll do is I'll also make the same change in Camel microservice a.pom.xml. So let's also use the same thing in here. So $camel.version. So those two changes are out of the way. And while I'm doing those changes, I see that everything has downloaded successfully and my projects are now set up. What we'll do is we'll not worry about Camel microservice B for now. Let's focus on Camel microservice A. Let's go in here and let's launch this application up. This does not really have anything yet. We will write a lot of code in here in the next steps. For now, let's just try to run it as a Java application. You can open up the Camel microservice A application, right click run as Java application, and it would launch up as a Java application. Let's make sure that it's starting up fine. Okay, finally it's launching up and I'm looking at the logs right now. And yep, the application launched up. It took about 9 seconds to launch the application up. That's awesome. In this step, we quickly set up the microservices that we'll be using in the next few steps. Welcome back. In this step, let's build our first Camel route. What is a route? Let's try and understand it while we build a route. Now, I'll go ahead and create a new class. So Control N, new class. For the package, I'll give dot routes and I'll give a package of A. So this is the first one that we are creating. That's why I'm calling it A. So dot routes dot A, and make sure that this route is created under a sub package of the COM in 28 minutes microservices, Camel microservices A. And over here, I'd want to call this my first timer router. So we'll use something called a timer to schedule things and run at regular intervals. Let's go ahead and say finish. Now you can see that there is a package which is created and my first timer router is created. What we want to do is to build a route. And to build a route, we need to extend something called route builder. So you can type in extends route builder and do organize imports, right click, and you can do organize imports, Control Shift O or Command Shift O, and you'd see that my first timer router would have a compilation error. You can do a Command 1 or Control 1 over here and say add unimplemented methods. In the configure method is where you want to actually create all your routes. Now, what is a route? Whenever we talk about Camel, what is Camel? Camel is a integration framework. So let's say I would want to actually listen to a queue. So I would want to listen to a queue, and whatever input that comes in, I want to do some transformation on it. I want to make some changes on the message which comes in. And finally, I would want to save it to a database. So these are the sequence of steps which we are planning to do. And this sequence of steps is what is called a route. And in this specific route, we have two endpoints. One endpoint is the queue. We are listening on a queue and we are saving it to a database. That is the other endpoint. So the two endpoints that are present in here are queue and the database. We'll talk a lot more about terminology as we go in. Let's quickly configure our route. For now, what we'll do is we'll not use a queue. What we'll do is we'll use a timer to actually trigger messages. And we'll not save them to database. What we'll do is we'll write them to a log. So we'll use timer and log as the channels. So we'll simplify things at the start. And as we go further in the course, we'll start using queues, databases, and a lot of other things. Now, I would want to start building a route. There are a lot of utility methods which are present in the route builder, which help us to build the routes. We'll use one of these, which is called from. So whenever you'd want to start defining a route, you want to specify the starting point of the route. From where? And that's the from. So in from, I'm specifying, let's use a timer. And because this is my first timer, I'll say timer first hyphen timer. This timer has to be as it is. This you can name whatever you'd want. So what we are creating in here is something called an endpoint. This is a timer endpoint. We are listening on the timer endpoint. And what do you want to do? Whenever there's a new message on the timer endpoint, what do you want to do? We would want to actually send it to a log. So we'd want to configure another endpoint in here. We want to send it to a log, and I would also call this first timer. The log and the timer in here and the log in here are keywords. The first timer is the name that I am giving in here. Let's see what would happen if I put a semicolon in here and save this. You can see that the application is immediately picking up the change. This is because of DevTools. And when I go into the log, you can see that there are total 0 routes, out of which 0 are started. I was expecting one route to be created. The route is not created. Why? Because I need to actually put a at component in here. So we need to define this as a component. I'll do a Control-Shift-O or organize imports, and I would want to import org Spring Framework stereotype component. Make sure that you are importing org Spring Framework stereotype component. And now I could go ahead and save this. And now let's see what's in the console. Now, when you look at the console, you would see that there is a route which is created. Route started and consuming from timer / first timer. Total 1 routes, out of which 1 route is started. And you can also see a lot of logs being triggered. I'll copy one of these and paste it right above our timer. This is a little irritating. So what I would do is I would say show console. So I'll disable the show console when started error changes. And I'll also disable show console when standard out changes. Okay. Let's get rid of that. Okay. Now I've copied a log message. Let's put that in here. You can see that the message has a body null. So the body of the message is null. You can see that by default, this message is being generated every second. So what the timer does is it generates a null message every second. And what we are doing is we are picking it up and sending it to a log. You can treat it the same as I'm picking up a message from a queue and I'm sending it, let's say, to the database or another queue. Instead of the queue, we are using a timer. Instead of the database, we are using a log. So these are 2 different channels and we are connecting them together. And in between connection of the channels, you can also do things. For example, I would want to actually transform this specific message. The message at this point in time, what is the message? The message at this point in time is null. I don't want null message. I would want to actually add something meaningful to it. Let's add some simple constant first starting off. So I'll do a transformation. So I'll transform the message and I'll want a constant message to start with. So I'll use a constant and I'll pass the constant value in here. So I'll say my constant message for now. So what we are doing is we are picking up the message from the timer endpoint. We are actually transforming it as a constant. So we are transforming the message as a constant, and this is the constant message we would want to send out. And we are now sending it out to the log. Let's save this and let's see what would happen now. Let's go back to the console, wait for the change to be picked up. And now if you go and look at it, the body is my constant message. So we picked up a message, a null message from the timer endpoint. We transformed it and sent it to the log endpoint. You can actually do a lot of things like this. Let me comment this. Instead of just a simple constant message, let's say I would want to actually add date time to it. So I'll say constant, and I can say time now is local date time dot nav. So this would give you the current time. Local date time is from Java 8. So if you're using Java version less than 8, this will not work. You should find some other way of doing it. But from Java 8, this code should work. I'll say save. Let's see what would happen now. Do you think what message would be printed? Aha, you can see that the time now is some time, but you can see that for all the messages, the time is the same. Why? Because this is actually using a constant. So what we are doing in here is creating a constant. Time now is whatever is the time at the evaluation time of the constant is being used. In this step, we started playing around with a simple route. We created one route with timer and the log as the endpoints. And we were also playing with a few constant transformations. Things in the real world will not be really this simple. In the next steps, let's see how to actually use Spring Beans as part of our transformations. And we'll also see how to pick up messages from queues like Kafka, ActiveMQ, and a lot of other things. Welcome back. In this step, let's continue our discussion from the last step and see how we can actually make this message dynamic. One of the options that we can do is actually create a bean to generate that message. Let's say I would want to create a bean in here. I'll say add component. Do not forget add component in here. And I'll say class get current time bean. And over here inside this specific class, I would want to create a simple method. Let's create one. Public string get current time. And let's return time now is local datetime.nav. So we are creating a very, very simple bean. And what we want to do now is we want to do transformation using that specific bean. What I can do is actually say dot bean, and I can say the name of this specific bean. Most important thing, it should be get with a lowercase. Whenever Spring is doing a component scan of this particular package, it would find this component. And what it would do is it would create a bean with the name get current time bean. And that's the reason why we are saying it in here as get current time bean. And let's save this. So we are using a Spring bean to do the transformation. And this bean would be invoked each time it receives a message on this specific endpoint. So let's see what would happen now. Let's see the time. You can see that the time in each of the messages right now is different. 985471, 7524, 2953, 7025, 1340. So that's working. One of the important things for you to understand is when you pick up a message from the queue, you would want to typically do a lot of transformation around it. Only after performing certain transformations or processing, you would send it out to a database or another queue. Over here, what we are doing is creating a simple component. Typically, whenever we talk about real-time applications, this would be really complex logic. Over here, to simplify things, I'm creating the get current time bean directly in here. Ideally, this should have been in a separate package of its own, as its own public class. One bad practice that we are following in here is we are having this bean name dependent on the name of this class. If somebody goes and renames this class and forgets to change the bean name, it would start failing. How can we avoid that? One of the best practices when it comes to using beans in a route is actually the better way of doing this would have been to do auto-wired and create a reference to the bean in here. So I would say private get current time bean, get current time bean. So we are auto-wiring the bean in. I'll do unorganized imports, and instead of doing this, now I can actually do this. So bean get current time bean. Oops, there's a typo in here. So get current time bean. Let's fix that. So now I have this saved. That's cool. That looks good. Let's save this and let's go and see what's happening in here. Cool. I see things continue to work as usual. Now, there is another thing which is very, very interesting in here. We did not configure get current time anywhere in here, right? So the method name we did not configure anywhere in here. If you want, actually, you can even configure get current time as the method name. You can pass it in here as well. So get current time as the method name. You'd see that it would continue to work as usual. And if actually pass in a different name, let's say get current time 1, what would happen? You'd see that it's failing. So method with name current time 1 does not exist. So method not found exception. And when you have just one method, then there's no problem. You don't really need to specify the name of the method. But when you have more than one methods in your bean, let's say there are a couple of other methods like this, then you need to go ahead and specify which method you'd want to invoke inside a specific bean. There are two types of operations that you can do within your specific route. One is processing, the other one is transformation. What is the difference between processing and transformation? Let's say once I receive a message, I want to do some operation or something which does not make a change on the body of the message itself. That is called a processing. However, if you are doing anything that changes the body of the message, then that is called a transformation. Over here, what we are doing in here is .transform.constant. We are transforming the message from null to constant message. The body of the message will change after that. So if I go in here and say .log, over here, let's say I'm doing a .log and log the body of the message. The way we can do that is by within double quotes, put dollar, within parenthesis, put body. So I'm logging the body after from, and I'm also logging the body after transform, and I'll also log the body after .bean. Let's save this. So these are the three things that I'm seeing in the log. Null is the first one, my constant message, and then this one. So when we did this, it was printing null. So over here, it's printing null. Over here, after the my constant message, it's printing my constant message. And after the processing of the bean, it's printing the time is something. So the time now is something. Let's put that in. So each of these operations where we are using a bean and we are using the transforms, these are all transformation operations because the body of the message is getting affected. In addition to transformations, you might want to do just some processing. You might want to take the body of the message, you'd want to do some processing with it and not really worry about changing it at all. Let's create a component like that. Let's just create a simple component. So let's just call it, let's say it does not do anything, like simple logging processing component. So this one, if you look at it, simple logging processing component, what I would do is I would actually say process. And the processing component does not need to return anything back. And the input to this can be the body of the message. So I can say string and I'll say message. And let's say over here, I don't do anything with it. All I do in here is say private logger is equal to logger factory dot get logger for this specific class. So this dot class, and let's just say I would log some message, logger dot info, and let's do dollar, and let's add in simple logging processing component. And over here I can put the message in. Oops, I don't need a dollar in here. it's just open brace, close brace should be fine, and this would be replaced with the message. Let's do an organize imports. Make sure that you are importing org slf for j logger and org slf for j logger factory. And you should see that the compilation of the class would succeed. And now I would want to actually make use of this simple logging processing component to process our thing. So I can say at auto wired private simple logging component. I'll just call this logging component. Let's say in addition to doing logging to the log, you are doing some special processing in here, or you are doing some logic and finally saving it to a database or something of that kind. So those kind of processing you can do in your beans as well. Over here, I can do .bean and pass in the login component. You would see that if I do a log body after the logging component, there will not be any change in the body. Go to the let's go to the console and see what's happening. You can see that even in the simple processing component, we are doing a simple log, but after the logging, there is no change in the message. The message remains, the body of the message remains exactly what it was before. The important difference between these two components, the get current time bean and the simple logging processing component, is the return type of the methods. You can see that over here we are returning a string back. In that kind of scenario, the body would be changed to whatever is returned back from this specific method. However, over here we are returning a void back. And when we are calling a bean method with a void, then it means we are doing some kind of processing in here. Whenever you are doing operations as part of the route, you would want to either do some processing or you would want to do some transformation. And that's what we looked at in this specific step. There are a lot more details that you need to understand about it. Let's dig deeper in the subsequent steps. Welcome back. In last steps, we talked about processing and transformations, and we looked at a few options of doing it. Whenever we talk about transform, we saw that there was a method called .transform, and .transform can be used to do your transformations, or you can also call a bean to do your transformations. And we also saw how we can actually do some processing using a bean. In addition to using a bean, you can also do processing of a message by creating processors. So you can say process. So you can say process, and you can, let's say, create a new simple logging processor. Let's go ahead and create a class called simple logging processor. I'll say command 1 or control 1 and say create class simple logging processor. And I would want to actually create it right here. So I'll say enclosing type in here and say finish. This would create a public class somewhere inside this class. This is where it actually created it. Let's pick that up. And actually I don't want to leave it public. So I'll move it down and I'll call this class. For this, we don't need add component because we are actually directly creating an instance of it in here. So new simple logging processor is what we passed in. And over here, you can do processing in here as well. So over here, you can define what processing needs to be done. For example, I would want to just do some logs. For now, let's just say over here, one thing is exchange is the parameter which is passed in. So I'll print exchange. And instead of simple logging processing component, I'll say simple logging processor. So we are creating a class which is very similar to this, except that over here we are implementing a processor interface. This is a predefined interface which is provided by Camel, and it defines exact method that we need to implement, and we are implementing this method in here. Let's save this. Oops, looks like there's an error. Let's see what the error is. Oops, there's an import which I need to remove. Let's remove the import, organize imports, save this. When you see what's happening in the console, you'd see that simple logging processor exchange is being printed out. If you don't want to print the exchange, you can also print the message. So you can say exchange.getMessage.getBody. So inside the exchange, the message is present and the message contains the body that we would want to print. So this is the way you can actually get the body out of the, this is the way you can actually get the body of the message. And if you look at the logs right now, you can see that even the simple logging processor is printing the message right now. So whenever we are doing some processing or transformation, there are two options that you have. So you can do transformation using the transform method or by creating a bean. Similarly, you can also do processing either by creating a processor or by using a bean as well. Typically, if you are very familiar with Spring, then you can use beans for both of them. In the last couple of steps, we discussed a little bit about processing and transformation of your messages. Until now, we have been playing with simple endpoints like timers or logs. In the subsequent step, let's start playing with files. I'll see you in the next step. In this step, let's start playing with files. What I'll do is I'll remove the add component on the my first time router. So I would want to actually create a new class for the files, and I don't want messages in the log from this specific component. So I'll remove add component, comment it out and save this. And when you go out, you should see that there is nothing in the log afterwards. So that's cool. Our first route which we have created is now disabled because we have commented the add component in there. And let's now go ahead and create a new route. So I'll go and create a new class. I'll create it in a package routes.b, and I'll call this my file router. So let's start playing with files, and I'll say finish. And what do we need to do in here? Extends route builder, and do a Ctrl+Shift+O, and now I can add the unimplemented methods, and this is where we can configure our routes. Now what we want to do is we would want to start playing with a few files. So from, I would say, file : and you can specify the path in here. Let's say all the files are in a folder called files. Let's call it files/input. Let's pick up all the files from an input folder and let's quickly move it to an output folder. So let's copy this and let's say I want to move it to an output folder. I've not created the files or the input folder right now. I've not created the files or the output folders as well. So let's actually go in and save this route. So we are creating a simple route. Whenever a file is placed in input folder, move it to the output folder. Let's save this. Let's see what would happen. If you do a refresh on the project, right click, refresh. Is this sufficient? There is just one more thing that we need to add in, add component, and say Ctrl+Shift+O, org Spring Framework stereotype component. So now you'd see that this route would be picked up. It's total 1 routes. So the route is picked up, the route, and I'll do a right click, refresh. Okay, there is a files folder in here with an input. So at the root, a files folder with input is created, and whatever you place in this folder would be moved over to files/output. The GitHub repository of the course is github.com/in28minutes/camel, and we made a few files, few test files available in 01.files. So there are a lot of files which are made available in here, about 8 files. I would recommend you to download them if you have not downloaded the source code earlier. So if you go back to the GitHub repository, go here, code, download zip, and you can download that specific zip, extract it. One of the folders at the root should be 01.files. What I would recommend you to do is to take those files, all of them, and copy them into the input folder in here. So I'll go into files, copy all of this, and the folder that we are looking at is the input folder over here, and I'll paste them in. As soon as you paste the files in, you'd see that they are already moved to the output. And if you go to the log, oops, there is nothing printed. The files are moved, but nothing is being printed. So let's actually go and see what's happening. So what I'll do is I'll do a log. So I'll say .log, and over here, I'll just say $ within parenthesis body and say save. And instead of moving all the files, what I would do is I'll just move one file from the output to the input folder. You'd see that the file is now being picked up. And if you look at the logs, you should see the content of the file being printed. And after processing, the file is automatically moved to an output. So what we are creating in here are two endpoints. As far as Camel is concerned, we are picking up a file from one endpoint and we are moving it to another endpoint. And as part of processing, we are actually printing the content of the body. As you can see, playing with files in Camel is very, very easy. Think of how much logic you need to write to be able to do something of this kind. With Camel, we are able to achieve this with just 3 lines. Welcome back. Starting this step, we want to play with ActiveMQ. We want Camel microservice A to place a message on the ActiveMQ queue, and we would want Camel microservice B to pick that message from the queue and process it. And to enable us to do that, we need to launch up ActiveMQ on our local machine. And we'll be using Docker to launch up our ActiveMQ container. If you're not familiar with Docker, or if you don't have Docker installed, then I would recommend you to check out the appendix section of the course. If you look at the appendix, there should be a section called Docker in 10 steps, and that should help you to get started with Docker. I would recommend you to complete that section and come back to here if you are not familiar with Docker. If you're familiar with Docker, just go ahead and type in the commands that you would be typing in right now. If you're on Mac or Linux, go ahead and use terminal. If you're on Windows, I would recommend you to use PowerShell. Otherwise, you can use command prompt as well. If you type in docker -5 version, you should see one of the latest versions of Docker. And the command to launch up ActiveMQ is docker run -p. There are a couple of ports that we would want to expose. The port where we would want to communicate on, the port where the management console would be running on. So docker run -p 61616 colon 61616. Another port -p 8161 8161. And next we would need to specify the Docker image that we'd want to launch up. The one which should be launching up is rmohr/ActiveMQ. If you do a Google for this rmohr/ActiveMQ, what we are using is the command which is present in here. Docker run -p 61616 8161 rmohr ActiveMQ. So the JMX broker will be listening on 61616 and the web console on 8161. And this is the Docker image that we would want to use to launch up ActiveMQ. So you can see that these are versions of ActiveMQ packaged into Docker images. Now, if I press enter in here, you can see that I do not have ActiveMQ image locally. So it would actually download the ActiveMQ image. The download would take a little while. And within a small while, it would start it up. The download of the image is taking about 2 minutes until now. And finally, the pull is complete. And now it's launching up ActiveMQ. Awesome. You can see that the ActiveMQ web console is available at a specific URL. I can actually go in and type that in the browser. It launches up the ActiveMQ console, and I would want to manage ActiveMQ broker. This would ask you for admin username and password. It's admin and admin. And you can go in. And once you go in, you should also be able to see the queues which are present right now. You can see that right now there should be no queues that are present. What we want to do is we would want to actually create a queue and have one of the microservices put the message in here and the other microservice help us to pick up a message from here. How can we do that? Let's see that in the next step. Welcome back. What we want to do is we would want to have the Camel microservice A put a message on the ActiveMQ. Let's see how to do that in this specific step. Let's say we would want to put a message every few seconds on the queue. Let's create a router for that. I'll do a control N. I'll create a new class and I'll create it in the package.routes.c, and I would call this ActiveMQ sender router, and I'll say finish. And this would extends route builder. Let's do a control1, import it in, and again control1 or command1, and add unimplemented methods, and let's go and implement it in here. Now what do you want to do in here? We want to trigger a timer, and in regular intervals we want to put a message on the queue. So the timer is one endpoint, queue is the other endpoint. So from timer colon, let's just call this active MQ timer. To the timer you can also configure a period. So you can say how often the message should be created. I'll say timer is equal to 10,000. So 10,000 milliseconds. Actually, it should not be timer, it should be period. We are configuring the time period as 10 seconds. And what I would do is I would for now just generate a constant message. I'll say transform dot constant. I'll call this my message for active MQ, and we would want to, where do we want to send this? We would want to send this to which endpoint? We want to send this to the queue, active MQ, and colon my queue, or I'll call this my active MQ queue, and put a semicolon at the end. Let's add an add component in here. Let's do an organize imports and import our Spring Framework stereotype component. Now, what we are doing is every 10 seconds, we are generating a message and putting it on the queue. Now, you might be wondering, this queue is not already present on the ActiveMQ queue. How would the queue be created? Before that, what we'll do is we'll go ahead and say save. So now I've saved this, and it would pick it up, and there's an error. So no endpoint could be found for ActiveMQ. So you can see that the component for this specific endpoint is not found. Earlier, when we use the timer endpoint or the log endpoint, these endpoints are already defined as part of the core classes in Camel. And that's the reason why you don't really need to import anything to be able to use them. However, as we discussed earlier, Camel wants to be lean, that is lightweight and extensible. So it only imports some of the endpoints and keeps the footprint very, very low. If you'd want to actually use any other endpoints like queues or databases, then you would need to import explicit dependencies for them. And these dependencies are provided by a number of components. And that's what we would be importing in right now. I'll open up the pom.xml. Make sure that you're opening the pom.xml for Camel microservice A. And in the pom.xml of Camel microservice A, we would configure another dependency. The dependency that we would be configuring is similar to this. So I'll copy this Camel Spring Boot starter. So I'll copy this in, and the starter is Camel. Do you want to guess? Instead of Spring Boot, ActiveMQ. And make sure that you're using same Camel version for both Camel Spring Boot starter and Camel ActiveMQ starter. And you can go ahead and save this. Now you'd see that the jars would be downloaded. So the dependencies that are needed for these are being downloaded right now. So you can see that by using the component architecture, you can only bring in the dependencies that you would need. You don't really need to bring in dependencies for, let's say, other queues you don't really want to make use of. And therefore, your microservices remain lightweight. Cool. I see that the import is now complete. And if you look at the console, you would see that still there is an error. Even after adding it to the pom.xml, there would still be an error, because whenever we make changes in the pom.xml, they reflect only when we stop and start the application. And that's the reason why I've stopped it completely. So I don't really have anything running right now, and I'll go in and run it again. So whenever you make a change to the pom.xml, you need to actually launch the application again. You need to stop and explicitly launch it again. This is because your dev tools is not good enough to pick up changes in pom.xml. So now when you actually go to the console, you would see that a connection is being established to ActiveMQ. So you can see that ActiveMQ 5.16.0 is starting. It started, and you can see that the connector also has been created. Now there is one more configuration that you need to do in the application.properties before we can use the ActiveMQ queue. That's the URL of the broker. So it's spring.activemq.broker-url is equal to tcp:// localhost 61616. Earlier when we launched up the Docker container, one of the ports which we opened up was 61616. And that's the port we are making use of to connect. So now you can save this, make sure that you stop and restart your application. Now, once you restart your application and check that there are 2 routes out of which 2 are started. If you don't see 2 routes are being started, make sure that you have ActiveMQ sender route with add component enabled, which is present in here. So this is one thing to check. In your pom.xml, you should have ActiveMQ dependency, and in application.properties, you should have ActiveMQ broker URL. These are the 3 things that are important. And once you have all of them running, you should see that when you go to the queues in ActiveMQ, there is a queue which is created, my ActiveMQ queue. And you can see that there are few pending messages in here as well. There are no consumers registered. There is nobody consuming these messages yet. But as you can see, every 10 seconds, a message is being put in there, and it would keep increasing. Now, for us to know when a message is being sent, what we can do is actually do a log. So you can say log, and let's just put a body in here. So log the body out, and let's save this. And now when we see the console, you should see something printed out. So every 10 seconds, you'd see that this message is being printed out. And when you go to ActiveMQ, you should see the number of pending messages increase. All the magic of creating a connection to ActiveMQ, creating the queue, all these things are happening because of Spring Boot auto configuration. Spring Boot auto configuration enables you to just focus on the business logic. You don't really need to worry about what is being configured and things like that. Now, we are able to successfully put a message on the queue. However, what we want to do is we would want to also take the message from the queue and process it. Where do we want to do that? We would want to do that in microservice B. And that's what we would be focusing on in the next step. I'll see you in the next step. Welcome back. In the previous step, we put a message on ActiveMQ. And in this step, we would want to actually process it from microservice B. Before we get started with it, let's do a little bit of configuration on microservice B and get started with it. Now, if you launch up microservice B as is, then you would get an error because it would be also using the default port 8080. And that's the reason why what we'll do is we'll configure a different port for it. So we'll configure it to use server.port is equal to 8000. And now I can go ahead and launch it. Before I launch it, I want to also make the same changes that we did in the pom.xml of microservice A in the microservice B. So let's copy in. Earlier in microservice A, we configured ActiveMQ starter. So we need to configure the same thing in the pom.xml of microservice B as well, because it needs to talk with ActiveMQ as well. So let's go ahead and add that in. So right below the Spring Boot starter is where I'm adding this in. So you can save that. And let's also copy the broker URL into application.properties of Camel microservice B. So over here, Camel microservice B, source main resources application.properties also has this. So both the application.properties have the ActiveMQ broker URL right now. And now I can go ahead and start up the application. So I'll go in here, right click, run as Java application. Let's see if this launches up fine. It should not take a long time to start up. Yep, about 8 seconds. And you can see that Apache Camel is started, but there are no routes that are configured. That's cool. Let's configure the routes right now. So I'll create a new class and let's call this active MQ receiver router, and I'll create it in a package routes again. So camel microservice b dot routes. Let's say finish. And over here, as usual, let's make this a component. Do not forget doing that. Add component extends route builder. Let's do an organize imports, serial type component. Let's do a control one, add unimplemented methods, and let's go and configure it in here. So what do you want to do? You want to pick up from which queue? Active MQ colon. What's the name of the queue? My active MQ queue. So let's paste that in. Oops, not the entire thing. I just want the my active MQ queue. That looks good. I would, for now, let's just say to log colon received message from active MQ. Let's put a semicolon at the end. Cool. Let's see what happens. Console. Oops, you can see that there are a lot of messages which would be received. So all the messages which were pending in the queue, they are all received right now. You can see that all of them are received, and once all of them are received, you would see that a new message will be received every 10 seconds. So I received a last one at 19:23:58 and the next one at 19:24:08. So every 10 seconds, we should start receiving a message from ActiveMQ. And if you go over to ActiveMQ and refresh, now you would see that number of pending messages is 0, because as soon as a message is put, we are being able to process it right now. And the number of consumers is 1. So we have one consumer looking at the messages and processing them. The other thing you can see in here is also the total number of messages which were placed until now. So you can see that until now, there are about 49 messages that are placed and dequeued, which are placed and processed. So that's awesome. So now what you can see over here is that we are able to process all the messages from ActiveMQ. We were able to put messages and we were able to process messages as well. Microservice A is putting the messages in and microservice B is processing them. In the last few steps, we looked at multiple endpoints. We started with timer endpoint, we looked at files, we looked at log, and now we are actually looking at ActiveMQ endpoints as well. You can see that irrespective of whether you are playing with ActiveMQ or files or log, it is very, very easy to do things with Camel. All that you need to do is to configure the route with the right endpoints and the right processors. That's all. Everything is automated for you. Camel enables us to focus on our business logic. In the subsequent steps, we'll actually play with a lot more examples. We'll also look at Kafka. But before that, in the next step, let's get a theoretical overview of what we are discussing. I'm sure you're having a wonderful time, and I'll see you in the next step.